So next we'll see about another very important algorithm, that is nothing but the Canny edge detection algorithm. So what is meant by the Canny edge detection algorithm? So it is basically it is based on three objectives, that is nothing but the detection, localization and single edge point. And what is meant by the detection? So detection is nothing but it maximizes the detection of the real edge points while minimizing the false positives. So that is a detection. And localization, it minimizes the distance between detected edge points and the true edge centers. Okay. And single edge point minimize the multiple edge pixels around the same edge. Okay, so this is the all these things are confirmed in the Canny edge detection algorithm, but these all things are failed. Okay, so only the detection of edge is possible in the Moore-Hildreth edge detection algorithm, but the localization and the single edge point detection is failed in the Moore-Hildreth edge detection algorithm. And how we are doing this algorithm? So we are doing this algorithm by the detection is done by the Gaussian smoothing and the Sobel gradient operators. So here we are using the Sobel, but in the Laplacian we are using in the Moore-Hildreth we are using the Sobel gradient operator. And the localization is done by the non-maximal suppression, and single edge point is done by the hysteresis thresholding. So this is actually a very interesting algorithm. So we'll see how to do it. So first, as we do, okay, so the Canny edge detection algorithm. So it's nothing but, so first we are doing the Gaussian smoothing and the Sobel gradient operator. So first one, what we are doing, we are smoothing the image. So here it's for example, I've given an image, the previous image what they used in the edge detection algorithms. So the input image is f of x comma y. It is first smoothened by a Gaussian filter g of x comma y to reduce the noise. So that is our first step. So this step is common in both Moore-Hildreth and the Canny edge detection algorithm. So how to find the Gaussian smoothing? If g of x comma y is equal to g of x comma y multiply convolution f of x comma y, where g of x comma y is nothing but your Gaussian filter. And after that, what you have to do? You have to find the gradient operator. So the gradient operator here in Canny edge detection we are using the Sobel operator. So your Sobel operator gx and gy is given over here. The gx is the image gradient in x and y directions are computed using the Sobel operators in both directions, that is gx and gy. So gx is given by dou fg of x comma y divided by dou x, and gy is given by dou fg of x comma y divided by dou y. The Sobel kernel operator in numericals also is given over here. So next what you have to do? You have to find the gradient magnitude. So like in the previous edge detection algorithms, detection methods we studied. So we have to find the gradient magnitude and the phase, right? So the magnitude is given by, that is mfs of x comma y. Here this is mfs of x comma y is the magnitude we are considering here. That is given by root of gx square plus gy square. So here in this figure you can see that all the x and y, okay, the horizontal and the vertical and the diagonal axis, everything are visible over in this figures. So that is a gradient magnitude. Now what we are doing? We are doing the gradient phase. Okay, so phase is given by tan inverse gx by gy. So this is the phase. So phase of the image. So what we can understand from this steps is nothing but in the step 2 it computes the the step 1 is nothing but your Gaussian smoothing, and step 2 it computes the gradient of the smoothened image, and gx and gy are obtained using the Sobel operator, that is the gradient magnitudes are obtained, and the gx and gy are the operators, and from the gx and gy we are finding the gradient magnitude and gradient phase. So the gradient magnitude will give you the strength of the edge, and the gradient phase will give you the direction of the edge. So this is all we have to do it. And next one is a very interesting thing. So it is nothing but the non-maximal suppression. Okay, so how to find a non-maximal suppression? So in the image we can see that So here, this is the gradient magnitude. It's over here. And this magnitude, what we are going to do is nothing but, so this magnitude we are going to plot in a gradient phase direction. Okay, so all these things, all this, whatever the magnitudes we are getting in the gx and gy, on the mod of gx and gy, that we are going to plot over, or we are going to we are going to overlap over a gradient phase direction. So the gradient phase direction, it is actually given in 4 directions or 4 different angles. So that is nothing but plus it is given by 157.5, 111.2, 67 and 22. So these are nothing but the positive values of this. Okay. So now what we are going to do. So here what we are doing is nothing but we are quantizing the phase into 4 directions. Okay, so each and every pixel is quantized into one particular edge. So whatever each and every pixels what we got in the gradient magnitude will be there, okay, in any one of this angle. So that is a total meaning of this. And next what we are going to do is nothing but, okay, so we are taking a we are finding the and we are finding the edge, that is m of x comma y. That is equation is given by m f of x comma y if m f of x comma y greater than m f of x dash y dash and m f of x comma y greater than m f of x double dash y dash. So it will be more confusing about this equation. It's very simple. So here what we're going to do is nothing but, so see here the example. Okay, so x and x dash are the neighbors of x along the h direction specified by a space value. So now I am going to take any angle, okay, any angle that is from plus 157 to plus 157 to minus 157, any angle I am taking. Okay, so in that angle I am just concentrating on any one of the pixels. Okay, so that pixel I doubt that it is a edge because already I found out from the magnitude. So the magnitude is already given, it's an edge, but I have to make sure that whether it is an edge or not. So how to find it? I'm taking that particular pixels, okay, and that pixel, okay, so that pixel will be in any one of the directions. So for example, this angle, okay, so this is an angle, this yellow line denotes an angle. So let's see that denote to and any one of the angle, that is plus 157 degree. Okay, so in that I'm taking the edge, whatever I'm doubtful, I'm taking it, and I'm going to see the neighbors of the particular x, okay, the angle or the pixel I am noting. So the neighbors of that particular pixel along that particular angle 157. Okay, now what I have to do, I have to check if it is an edge, that if it is an edge m of x comma y, only if, okay, only if this particular angle, okay, if it is greater than this pixel, the magnitude of this pixel, and is also greater than the magnitude of this pixel. Understood? Then only I can make it as what it is an edge. Otherwise I won't be able to make it as an edge. Okay, I won't be able to write it as an edge. And another, it is nothing but it is around the 0 degree axis. Another I am taking the 45 degree axis. So in the 45 degree axis also I am taking a pixel, okay, and I am taking a pixel from the gradient magnitude and checking the neighbors. Okay, neighbors are x dash and x double dash. I am checking the neighbors along the particular direction, and I am also checking whether the magnitude of both the pixels are greater than the magnitude of this. Okay, if it is greater, I can make it as a edge. Otherwise, I won't be able to make it as an edge. So in this, both the steps, what you are understood. So this is x is nothing but a dark pixel. Okay, it is a black pixel. But other two neighboring pixels are gray, right? So what do you understand? The black pixel is less than gray, right? So I won't be able to make this x-axis a edge. So here also same thing. So for example, okay, so for example, both the things, okay, so if I am taking this instead of this black pixel or instead of the 0 pixel, I am taking as a white pixel. Okay, this then what do you understand? So if it is a white pixel, what I can understand, Okay, so and these two things are gray pixels. So the white pixels is more than what? These two pixels. Okay, then I can make what? This X as what? My edge. Or else in another case what I can put? So let this center be a white pixel and this be a gray pixel and this be a black pixel. Okay, in that case also what I can do? So the white pixel is greater than the white pixel is greater than the gray pixel and the black pixel. So I can write that as a what? My edge. Okay, so this is what this equation gives. So this is the quantized direction. So quantized direction of this it is given here. And after non-maximum separation, so it is entirely different from this gradient magnitude, right? So whatever the pixels that is greater than the particular neighboring pixels, only I am taking as the edge. Other things I am discarding. Okay, so this is meant by the non-maximum separation. So that is a step 3. So next what you have to do is nothing but you have to do the hysteresis thresholding. Okay, so here this step 4 we are having two things, hysteresis thresholding, and also we are having the next step hysteresis and the thresholding. Okay, so that we can tell it as okay, both. So in this what we have to do is like instead of standard we are considering a single threshold, a double thresholding is given over here. Okay, so the double thresholding steps aims at identifying 3 kinds of pixels, that is a strong, weak and a non-relevant pixels. So a double thresholding, so like for example a double thresholding can be done so we can find a double thresholding like this. So we are having 2 thresholding will be there. So we are having a lower threshold here and we are having an upper threshold here. Okay, so we are having an upper threshold here. So here, so that is why we are telling it as a double thresholding. Okay, so the double thresholding, that is nothing but anything below the threshold value 0, anything above the anything like double thresholding means anything below lower threshold is 0, anything above lower threshold keep an intermediate value, and above the threshold that can be given as what? White. Okay, so here we can give it as so lower threshold, here anything below this can be given as a black, and here this we can give it as a gray, and above the threshold will be what? The white. So this is all like the edge white. So this is how we are doing it. So what are strong pixels? Strong pixels are pixels that have an intensity so high that are very sure to contribute the final edge. So that are the white pixels. And weak pixels are the pixels that have an intensity value that is not enough to be considered as a strong edge, but yet not small enough to be considered as a non-relevant for the edge. So this is our thing. So this weak pixels. So the weak pixels only we are having like not enough to be considered as a strong one, that is a black one, and other pixels are non-relevant for the edge. So in this two between the gray pixels, so that can be a chance that it can be a edge, it cannot be an edge. So there only the confusion starts. So now so we can see how to do it. So after maximum separation we have to do the double thresholding, apply 2 thresholding over it. Okay, and the strong pixel, weak pixels and non-relevant pixels are located, and after the hysteresis thresholding we'll be getting a thing over here, an output, an image over here. So all the strong pixels are immediately accepted as edge, weak pixels are included in the final edge or if they are connected. Okay, all other pixels are supposed to be on the non-edge range. So now we'll see how to do this thresholding. Okay, so like we have done the double thresholding, now we will see how to do the hysteresis. Okay, so in this we have to see, okay, we have to based on thresholding, hysteresis consists of transforming weak pixels into strong ones. Only if there is a condition if and only if one of the pixels around this one being processed is a strong. So how to do? So now we are having a weak pixel over here. So we just omit about the black and the white. So the black and the white, black is nothing but it is not at all an edge. White is surely it is an edge. Whatever it is coming in the gray, we are having the problem whether it is an edge or not. Okay, so that we have to consider. So now we can see here we are having a gray pixel over here. Okay, and we have to check about all the 8 neighborhoods. Okay, all the 8 neighborhoods. So what are the 8 neighborhoods? All the things are nothing but here this and this it is given it as black, and all other neighborhoods it is coming as well the gray. So now we can surely tell this is not an edge. Now see this condition. So we are having a center pixel, that is a gray pixel. Now we have to check whether it is coming into an edge or not. So in this we have to check all the surroundings, all the surrounding 8 pixels. So we are surrounding, so we are having a gray over here, we are having black over here, here black, here gray, and here we can see a white pixel. If that white pixel is coming, what is the meaning of it? This, if any of the neighbor is greater than the particular white pixel, then we can consider this also belongs to what? The particular edge. Okay, this also belongs to particular edge. So this is why it is, this is what is given over here. So here this was a gray pixel, as one of our neighboring pixel is greater than the white pixel, then we can surely tell this is also comes under the, this is also a part of the edge. Okay, so this is what the hysteresis thresholding. So here we can see after this, so you will be getting all the double thresholding over here. After the double thresholding, if you are applying the hysteresis thresholding, you will be getting a final edge like this according to the Canny edge detection algorithm. So the Mark-Hilgerth and Canny edge detection algorithm, so what is the difference? Is nothing but it's given here. Mark-Hilgerth algorithm, you are having a Gaussian filter, then you are doing the Laplacian and thresholding based on a 3x3 panel and the sign change. And Canny edge detection algorithm, you are having a Gaussian filter again and a Sobel operator, and then you are doing the non-maximum suppression and the hysteresis thresholding. So here it is the like output. So this is here given in original image over here, then the thresholding, that is smoothing image, and this is this image shows the Mark-Hilgerth algorithm and this shows the Canny edge detection algorithm. So the Canny edge detection will give you more strongest edges when compared to the Mark-Hilgerth edge detection algorithm. So that's all about the like the Canny edge detection algorithm. So basically, so we'll see once again, we'll remind about what is the Canny edge detection algorithm. So this is nothing but, so we are having basically in Mark-Hilgerth we are doing only detection, but here we are doing the localization and the single edge point. So what are the basic steps and nothing but the detection can be done with the help of the Gaussian smoothing and the Sobel operator. So in this detection we are finding the phase and the magnitude of the edges, and in the localization we are doing the non-maxima suppression. So in this we are making sure a particular thing that we are detected as an edge or not using a non-maximum suppression or the phase quantization technique, and finally we are finding a single edge point using a hysteresis thresholding. So here again we can see like so smoothened image, and you're finding the gradient magnitude, and what you're doing next one, the magnitude are mapped over a particular quantized phase. Okay, and in each pixel we are taking around a particular angle on that particular phase. Okay, when we have to check the neighboring pixels are greater than that particular center pixel we have chosen. If it is so, we can consider that as an edge, otherwise we have to discard it. And next we have to do the double thresholding. So in the, we can't do whether it is a black and white. Okay, so black means what? It is not an edge. White means it is an edge. But we are having some condition in which an intermediate things are there. So we have to apply what? The double thresholding over here. So when we are applying the double thresholding only, we can consider more clarity about the particular edge. So this can be done using the hysteresis method. So in this hysteresis method, what we have to take a weak pixel and we have to check the intermediate pixel we have to take, and we have to check for the 8 point neighbors of the edge, and if any of the point neighbor is greater than the particular intermediate pixel, okay, then we have to make that also as a particular edge. Otherwise, we can discard it. So this is all about the Canny edge detection algorithm. I hope you all understood this.